Andrea Ferraresi, Principal Solution Architect with Red Hat, and I'm here with Sonal Rattan, CTO at eXate. And today we will talk about digital data sovereignty. Sonal, do you want to introduce yourself?
Yes, so hi, I'm Sonal. As Andrea mentioned, I'm the CTO and one of the co-founders of eXate. So background has been lots of software engineering and also leading lots of software engineers and data scientists at a variety of financial institutions. Ended up setting up eXate to deal with so many different issues that I had in my corporate career with trying to achieve a global operating model and different data sovereignty requirements, which ended up causing me to have silos within my organization, which is one of the things that we're looking to actually solve with the combined effort between Red Hat and eXate. So thanks for having me.
Thank you, Sonal.
Yep. So should we kick straight off and we'll go into what we've actually done, like the exciting stuff. Okay. So I think the best thing we do is just start with level setting with what's actually happening and why is there a rising pressure on data sovereignty, especially in today's climate. We all know about the hacking and all the different things that we're seeing around ransomware, etc. But there are bad actors out there, especially nation states as well, which are stealing precious data to get for monetary gain. But it's not just data that they're taking. Obviously, there is a lot more that's happening in this space. But this has now led to 137 countries now creating different data protection laws, with 40 of them having data sovereignty requirements. If we look at data sovereignty, there are a variety of things that we're talking about what that entails, but some of the main key ones, especially when we look at data localization, are the ones that are causing key challenges in today's era. So what does it mean for global organizations? So one of the big things that I wanted in my role, so I was a CTO, led CTO function for digital transformation at one of the banks that I worked at. And the key issues that I had was I wanted to operate software globally, but then also be able to comply with all the regulations locally. But with things around data localization requirements, we had so many different challenges when we were trying to have one system that could facilitate the rest of the world. And if we were able to achieve that had so many different benefits, including better experience for customers, less systems to be onboarded onto, consistency when we're moving data across. We had so many benefits of just having one single system that we could have used and to be able to service the rest of the regions. And that was one of the key things that I wanted, was the ability to bring back this global operating model. But the blockers for us were data residency. So there are certain things, and this is so just to level set the language around this. What do we mean when we talk about data residency, data localization, and data sovereignty? So with data residency, it's usually an organizational policy that driven off some legislation. So like under GDPR, you can store EU data on EU data centers. So that'll be an example of that. But that does mean that you can still share with other member states of the EU and any other jurisdictions that have a compliant data protection regime in place. So it does allow cross-border data transfers, but it's usually driven by an organization. So I want my software there and I can service it out. When we talk about data localization, that is a legal requirement where you're told to keep data within countries. So this is where it prohibits you from sending data cross borders. So an example of that would be China, where they're requiring their citizens' data to stay within China and on China's data centers. And then data sovereignty is almost like a combination of the two, where we've got we may allow cross-border data transfers, but the data must remain with the subject of the home country's law. And a big example of why we're seeing a big change in the data sovereignty space is things like the US Cloud Act, where the US authorities have got access held by US companies abroad. So that is it's starting to bring a new dimension to when we're talking about who actually has the ownership, who's the ultimate decision maker when we're in the cloud era. So when we talk about the US Cloud Act, it doesn't just refer to hyperscalers. It is an acronym which deals with any American tech company. But the issue is before, when we were on our own data centers, the organization had ultimate control on where they would give that data up under a subpoena or anything like that. Now, under the cloud era, there are some new challenges that are in play, which means that does the cloud provider have a say? Can they just send your data across? And to deal with those things is what eXate came about, to actually ensure that you have that sovereignty on your data.
Yeah, I guess something that is often kind of underlooked is the fact that when you're running something on the cloud, you don't always have control where those data are, so they could be replicated somewhere else. And in certain countries like Switzerland or the US, the fact that the data needs to be physically in the country it is a problem.
Yeah, and these are some of the key challenges that we're helping organizations with. But that we were just talking like specifically about data sovereignty there. But if we look at the overall what we're here to talk about today, which is the digital sovereignty side, this is some of the exciting work that we've been doing with eXate and Red Hat to talk about how do we actually achieve that overall digital sovereignty. So we can see that it's the three pillars are data sovereignty, technical sovereignty, and operational sovereignty. I've just highlighted the parts that we know Red Hat do, and they're servicing probably most of the world's organizations with in some respect with achieving some of these things. But where eXate and what we were bringing to the table was looking at the overall data sovereignty space, looking at data protection at rest, in motion, and in use, the data residency and data localization side of it, and also the transparent and auditable operation. So what we were looking to do is to bring our technology into the Red Hat stack to be able to give a more broader offering with that data sovereignty side of it. And it was a partnership it was just made to happen, wasn't it, Andrea?
Yeah, I mean, eXate is let's say a data company, and Red Hat is not. So we've always been working on, trusted software supply chain, certified network integrations, and all the network security, but we don't deal with data, and that's where the match made in heaven was possible with eXate, because data privacy is actually your bread and butter.
Yeah. So this is how IDC are defining what digital sovereignty is. But if we look at how Gartner is placing it, and how Deloitte's, the KPMGs, all of them are coming to the same language, where it may be some variant, but it's roughly around the same. So data sovereignty, infrastructure, operational sovereignty, and technical sovereignty, which is all of the things that we needed to bring together to really truly achieve full digital sovereignty. So our vision, so we spent about 18 months talking about, not talking about, actually doing. We spent probably 2 years overall, but we spent about 6 months looking at how do we actually achieve what the dream was. This is what I left my corporate career for, was how do we actually unify the digital sovereignty with data, infrastructure, and operations, purposely built to operate globally and comply locally across all cloud providers. And that was one of the reasons I actually sought out Red Hat for this. I wanted to have a solution that was going to be able to run across all cloud providers. So we know with the hyperscalers, they're not looking to go into every single country. But as an organization, I'm not going to be driven by where a cloud provider is going to put data centers in place or where they're going to achieve partnerships. So what I needed was the ability to work over multiple cloud providers. And that was where Red Hat really excelled, in my opinion, where with that hybrid cloud and being able to provide a hybrid cluster, we were able to very, very quickly create a solution that we could integrate all of those things across and be agnostic of what the infrastructure that we're using. And a part of the digital sovereignty requirements are technological independence. So if you are meeting those regulations, then being tied into a single cloud provider may not always be the right answer for your organization. And this is where technologies like this start coming into play. And Andrea, I don't know if you want to add anything here.
Yeah, I mean, as I mentioned before, being able to deal with infrastructure and operation has always been our focus in Red Hat. While dealing with data and do so across all cloud providers, or even on-premise or mainframes and whatnot. So we've always been a kind of a infrastructure operation company. So yeah, what Sonal and eXate brought us was actually the ability to deal with the data while complying with all the regulations and that we've seen that are now being globally enforced.
Yeah. So introducing what we've actually done. So we've got our sovereign hybrid multi-cloud. So this is, we know Red Hat's already big in the space for sovereign cloud. We wanted to bring that data aspect into it, which is what we've been focusing on over the last 18 months. So between us, we're able to service that end to end from a digital sovereignty standpoint. Again, being able to deal with the data privacy and data localization requirements that are in play means that we can innovate more in this space while still having global operations. And this is what really excited us when we actually set out to actually do this. So to introduce what we've actually got, I'll let Andrea talk about what the Red Hat side is, and I can talk a little bit about the things that we brought into it as well.
So yeah, I mean, if you ever came across OpenShift or Kubernetes, you will know that OpenShift is a distribution of Kubernetes, and it has Kubernetes at its core. But our very close focus when we built OpenShift was to make it possible to run it on any possible cloud or any possible data center, for that matter, exactly in the same way. So our focus has been, all right, we want to have the same organic and the same organic experience across all the clouds. So that's where we were focusing. So when you have OpenShift on, say, AWS or Azure or on your private data center, the look and feel and what you can do is exactly the same. So that's actually what we've been trying to do and been able to do while building OpenShift. And then, we found eXate as a data protection platform. And as Sonal already spoke about it, was this kind of match made in heaven, because they can automate security and data privacy into the application. So now, with the combination of both solutions, we can actually cover the entire stack from the data up to the application in this sovereign hybrid multi-cloud kind of infrastructure.
Yep. So what we bring together is, again, that sovereign cloud that we spoke about, that Red Hat do so well. But we're bringing in data privacy into the solution. So as a platform, we sit at the intersection of four things. One's data classification, which we can do in real time, data privacy and data protection. So we've aggregated multiple privacy enhancing techniques into one platform, but we can also look at cell level data and determine whether or not someone's given you access to do that, have they invoked their right to be forgotten, those types of actual things that the data protection regulations are asking you to do. Data sovereignty, which is being able to do data protection and keep them local and keep data within jurisdiction and inject them back in at runtime. And then key sovereignty, which is a part of one of the white papers that we're about to release, to talk about why sovereign keys actually help us when we're looking to operate still with the hyperscalers, which again are still our partners in this, but being able to make sure that your data the ownership comes back to you. So we're bringing all of that together to allow organizations to very easily be able to bring the data sovereignty side into that sovereign cloud and bringing those two together. So how did we, what have we done? How we look to approach this issue? So I'm going to hand over to you, Andrea.
Yeah. So eXate works on Kubernetes. So what we did was having multiple Kubernetes OpenShift clusters across the world, actually, and with OpenShift based on it. Now, how did we used ACM, Advanced Cluster Manager, to create all those clusters in a way that both the application and the overall infrastructure was kind of same across the regions. And we did the plumbing using Red Hat Service Interconnect, which is a Scapper-based multi-cluster communication tool that substantially what it does is that it kind of make the application believe that even if it's running in multiple clusters, feels like it's all in one cluster. On top of it, we installed eXate and data relevant application that we will show in a bit with a demo. And we also used a route decision service that basically is able to run the application on the target cluster. So basically we used OpenShift as the container orchestration and eXate's data governance tool.
Yeah. So just to talk a little bit about Service Interconnect. So when we first had the meetings with the teams that are working on Red Hat Service Interconnect, which is built on Scapper, I think it was a game changer for us. This is exactly the thing that we were looking for when we were looking to achieve this combined product. What we were looking to do from an eXate perspective is make Kubernetes to be data aware. So that's what our service does. It can look at the data set itself and then work out where am I allowed to be run? What conditions do I have? What policies are in place for me to be able to use that data in a global way? Might be something around India payments, for example, which has to run in jurisdiction. It can't run outside of India. It has to be on India data centers. You may have servicing Swiss customers, which have to be in Switzerland. Again, similar sort of requirement from a data localization requirement. But how do we actually look to operate globally, have one system, and it behaves like one system, but it runs exactly where it's supposed to run and it meets the requirements that we're looking to do. And Service Interconnect, for me, from a technology standpoint, has got so much use in this space, which means that we can innovate from building new versions of federated learning or those types of things. This will be the underlying infrastructure and software combination that makes it feel like it's one. And we've got that data aware side of it that can actually say where something can run. And to talk about some of the plumbing and what actually happens, I'm going to hand over to Andrea again.
Yeah. So Red Hat Service Interconnect, that is based on Scapper again. It's kind of a bit of an underdog. It hasn't been that widely spoke about, but it's actually a very, very powerful tool. What does it do? It does a lot of things. It can do orchestration. It can be used for DevSecOps. It can be used for observability. So basically, what it does is that it creates this layer 7 network across multiple Kubernetes infrastructures or clusters, and it can deploy basically anywhere. And then from there, it enables you to kind of observe and analyze what's going on inside the networking. So basically, it makes your application feel like as can run everywhere. Can you go to the next slide? How it does it is using a virtual application network. So it has a routing mechanism, and it can learn using shortest path message, what is the fastest route to go from A to B. It can do forwarding, it can do application isolation, it can do resiliency and all this kind of stuff. So not only can be used also to preserve this PCI DSS type of policies, because you can do application isolation. But the most important thing is that the network is ephemeral. So if you don't need the network to be there, you can actually just disconnect it and then reconnect it. And it's so granular that actually you can not only connect the entire cluster with an entire cluster, but also only the application, or even only the project or the workspace. So it's extremely powerful in terms of what it can do in terms of networking. Can you go to the next slide?
Yeah, just to add to this bit, one of the things that when I was looking at it from a data standpoint, I was looking at it, the fact that if again, looking at what the geopolitical situation is at the moment, what happens as new countries start bringing in law around data localization? How easy is it for me to extend this to be able to then bring on another country, and how quickly can we orchestrate that? And we were able to demonstrate that with Service Interconnect. It's very, very easy to bring up another cluster and connect it into the network, and it's all secure. So that was a really big part. I thought that.
Yeah, again, I think actually the interesting bit is also the opposite. The fact that you can remove easily clusters, yes, and that the network doesn't need to be there all the time. So even from a security standpoint, is actually much more secure than just kind of having a solid link between the clusters. Sorry, I interrupted you.
Oh no.
So yeah, basically what we did is we have so we will show you a demo now in just a little bit, and the way, and this actually can showcase what we can do, and Sonal will talk about it in a bit more kind of detailed way. But yeah, just to see kind of the 7,000 feet overview of what we've done is installing several OpenShift cluster across different regions, while having one global, so one central one. So imagine if you are a bank or a insurance or whatnot, and you have different entities on different parts of the world. So you would have to have your main office, which is represented by your OpenShift global gateway or global cluster, and then you would have something in UK, EU, and the US. Now, how can we access those data and without actually moving the data around? So bringing there effectively the computational power, while preserving digital data sovereignty. And the way we did it was using Scapper. Scapper has a little router that actually uses some of the eXate intelligence to figure out which cluster needs to deal with which data. It can the router can be obviously can be done in several ways. We just did it in the simplest way possible, but it uses some part of eXate to figure out where those data needs to be dealt with. And with the Scapper global networking, we can actually tell the application to run on each of those clusters and then send back the informations already after they've been manipulated.
Just to also add, so all of the things that are in scope for data localization requirements and for, again, for that data sovereignty requirement, the eXate services, which actually does encryption of all the fields that are in scope. So that will be any personal information or any sensitive information that is covered in scope for digital sovereignty, can run on confidential computers. So that the underlying, we've got that hardware to ensure that the pods itself are encrypted, and there is no way to be able to access them. They go through attestations, etc. So it is proving and auditing, and it is ensuring that all of those things combined have got all of the privacy techniques in place to show that you've got full control of that. And where we leverage that confidential compute, we can see that our service, which is the eXate service, is the thing that will be leveraging off, and it is distributed using confidential compute. So that is where all the encryption decryption happens, but we're making sure that that only happens within the jurisdictions it's allowed to be done. So in Switzerland, there will be a case where encryption keys, say if we are using encryption, encryption's not always the right technique. We aggregate multiple techniques. Sometimes we have to use tokenization. So we break the math on what's actually is allowed to be stored in the underlying system. But the thing that actually reconstructs and rehydrates that payload is the thing that sits on confidential compute. So I think it's also worth bringing that in, that, again, some of the great work that's been happening within Red Hat, we're leveraging off what we're able to do for infrastructure standpoint and from the technical standpoint and the auditability for there, and be able to deal with in a very, very extremely secure, that in a more almost like a paranoid sort of way, that we've got everything so tightly controlled within there that we're able to then audit that and be able to show that we can actually operate globally and we can prove that we're complying locally. So
just one thing on confidential computing. This is a kind of very very pertinent thing. As of today, the trustee, that is our confidential computing solution for Red Hat, is finally GA. This is August 2025. Just for
great
following live.
Yeah. So in terms of the demo, just to talk through what it is that we've got. So we had two clusters. So we had a European cluster, which is the Alpha cluster, and we had separated the payment service for the UK and for Switzerland as two completely separate namespaces within the cluster. But we just wanted to be able to show isolation. So again, there is no overlap. If there is something that needs to be run in the UK or in Switzerland, we're able to, and any countries that can be serviced by either country, again, it will pick the fastest path with the work that we've done with Scupper. And then we've got a beta cluster, which is the US cluster. So again, looking at some of the things around Schrems 2, the requirements from US Bulk Export Act as well, where data can't be shared outside of the US in certain scenarios as well. It is also in reverse. We're just isolating the instances, but we've got a common instance that we're using. So we've created, we essentially just used one of the example patient portal services just to show as payments. So we're not going to go through showing you the patient portal. That's not probably the interesting part of it. But what we're going to focus on is running payments in different countries, which is one of the sensitive operations that some countries do actually say that is in scope to be local. So because that's your economy, I guess. So this is the example that we've done. So we've got two clusters, and I'll try to slow it down to be able to talk through where we're proving things are running, depending on who the user is, where something actually runs. So with that, I'm going to kick off with the demo. So the application that we've got is a patient portal. And what we've got with the patient portal is actually running payments. So what we're saying is that the entire application can run globally, but it's the payments that has got the requirement to run in jurisdiction. So here we've got regional routing for the UK patient. So as soon as they click a payment, it will get run in the UK cluster. Same with the Swiss and we're then finally going to show the US patient, which actually runs on the beta cluster, which is the example that we just ran through. And then finally, we'll go through that data access and auditing side of it to say what rules were in place and how that was actually done. But we will start with the encryption side of it, but we're going to talk about the configuration part first. So this is essentially what Scupper looks at. This is the topology that we set up. So when we're talking about the payment service being set up in UK, Switzerland, and the US, this is what that looks like and how we actually get that set up. So over to you, Andrea, to just talk through this part.
So yeah, basically we have a central cluster, as I mentioned before. That central cluster, you will see it in a terminal called as hub. And then we will have several clusters. One is in UK, one is in Switzerland, and one is in the US. The fact that we choose these 3 countries is completely random, actually. But yeah, so what we want to show is that the payment service can actually figure out where the payment needs to go, and only the country that needs to process that payment will be processing it. So as you can see here in the topology, the topology scheme here, you can see that basically how Scupper is set up. Again, it's probably worth mentioning. So one of the fact that we're showing a patient portal and a payment service is because everything we built is industry agnostic. So everything that has, like any highly regulatory requirement can be for data. You can use this implementation. So it's not only for banks or healthcare. It can be used for everything. All right.
So these are just showing the nodes and how it's actually been set up. So very easy user interface. This part is just showing how we actually pseudonymize the data in the underlying database. So this is the eXate portal and how we want to we intercept payloads as they're going in. So on ingress, if there are any fields that need to be protected, we will encrypt it before it gets stored at rest in the database. And then when it comes back out, we will then do a rule evaluation to work out whether or not you can see that information. This is the part that we extended to say when we understand what that data is and whose data we're looking at, when we're doing that decryption, it's working out what jurisdiction does it need to be in. And that's what invokes the Scupper network to say, actually, so this runs in the hub to say this is where it needs to run. And then any decryption happens within jurisdiction. So this is just showing an example of a payload that sits behind the hood with this, and being able to just take fields and encrypt them and then pseudonymize them. So we're tokenizing them for this purpose. So this is just to show in the underlying logs that you can see that the data, all of the data that is sensitive is in its protected form. So example 1, which is that UK patient. So you can see here, we've got the hub. So every single payment that will go through will go via this hub here. And we've got the payment service in GB, Switzerland, and US. So these are all listening to see which one needs to be actually used to be processed. So here we've got one unpaid bill for the UK patient. You can see it's Angela Martin. She's about to pay her bill. So you can see that it went to the hub and then it's gone straight to the UK payment. None of the Swiss or the US services have actually picked that requirement up. So it's processing that payment within the UK. And we're going to show exactly the same thing with a Swiss patient next. And again, it will show that it will go through to the hub first. So as we pay that bill, you can see that it is processed within the Swiss cluster at that point. And then finally, we're going to be going to the beta cluster, which is just to showcase the US bill being paid. So we're going to submit that payment, and you can see that it's only being processed by the version that is permitted. To look at that data access and auditing side of it, so we've got the audit logs within. Again, these are published via standard out, so you can put it into your own syncs. So here we're just showing why information can be accessed. So this is a US doctor and he can only see US patients' data. And if you want to just check what the underlying rule is for that, here is what kind of information is in there, what countries are we servicing, so these are the rules that sit underlying behind it, and what are the claims. So it's a quick run through of how that information, how you can pick up what rule was run at any particular point in time, what was the entitlement, who was the individual that was trying to access it, where was it processed. All of that audit information is stored within the system, so you've got all of the evidence that you might need for that. And again, going back to that full end-to-end digital sovereignty side of it, what we're looking to do is being able to service and run pods anywhere. Again, operate globally. We've got one system that can service every single country, but where there are requirements, we can ensure that it runs in jurisdiction. So like what we've brought together here is that using Red Hat Sovereign Cloud capabilities, we've incorporated the data privacy. So we're ensuring we're meeting data regulation where data is actually protected and it is stored in its encrypted state or pseudonymized state, depending on what technique you want to use. We can check whether or not from a data localization requirement, are you allowed to see that information and are you allowed to process it? If not, where can it be processed and auto-route it? We've got the data sovereignty piece, which is, again, keeping encryption keys and any tokens within jurisdiction. And key sovereignty is a part that we'll be talking about in our white paper. That's the link should be available in the link below, which is talking again about why sovereign keys and HSMs are so important in this space as well. With that, I'll hand over to Andrea.
Yeah, I think thanks a lot for the demo and for showing what we did. I think it's very important to kind of again stress about the main things here. So one, this can run, eXate can run, so the solution can run on any cloud or on-prem or even mainframes. So this can run anywhere. It will always kind of look the same. It's very important also to notice the fact that what we wanted to show is that you can actually on demand process data in country in a completely secure way. And the fact that you can build up those links very quickly makes it possible to not only expand the possibility that your company has, but also or that your data sovereignty requirements need, but also the fact that it can be used anywhere in the world at any time, but also that you can reduce the number of countries in which you can operate. So, and this is completely elastic. And yeah, besides that, again, if you want to read more about it, as Sonal mentioned, you can click on the link below and have a look at our white paper about digital data sovereignty. And yeah, thanks a lot, Sonal.
And thanks a lot, Andrea.
And thanks everyone for listening to this webinar today.
Thanks.
Bye.